Hello and welcome. We are glad you have joined us. My name is Amit Neal. I'm a Microsoft technical trainer specializing in security and AI. I am here to walk you through the AZ-305 course, Design Infrastructure Solutions. In this session, we will design a data integration solution that brings data together across Azure services. We will explore how to choose the right Azure service and architecture to support batch and real-time data movement, analytics, and integration at scale. We will cover how to design a data integration solution with Azure Data Factory and Azure Data Lake. Design a data integration solution and analytics solution with Azure Databricks and Azure Synapse Analytics. Finally, design Azure Stream Analytics solution for data analysis. So let's get started. First, we'll look at the end-to-end analytic and integration because once we see the flow, every service lands in the right box. We start with the data. It might be IoT telemetry, files, logs, structured or unstructured data. Then we ingest, for example using Azure Data Factory or Event Hubs. We need an analytical data storage like Azure Data Lake. After that, we can process with Azure Synapse Analytics Pool or Azure Databricks or even in real time with Azure Stream Analytics. Next, we enrich with Microsoft Foundry, for example. Finally, we serve with Power BI, for instance, so users can consume it through dashboards or applications. When exploring integration solutions in Azure, we can consider more options to support apps and system integration for internal or external services, even for hybrid and multi-cloud solutions. For Azure Logic Apps and Azure Function Details, watch the Design a Compute Solution Part 2 video. For details about Service Bus, API Management, Event Grid, look for the video Design an Application Architecture Solution. In this session, we will explore Azure Data Factory. Let's begin with Azure Data Lakes. We design for Azure Data Lake when we need analytical storage optimized for big data. Azure Data Lake storage is built on top of Azure Blobs. Azure Data Lakes leverage locally redundant storage protected from internal data center failures. It is scalable and cost-effective, a perfect match for big data analytics scenario. We don't buy a separate data lake. We enable data lake capabilities in storage account by turning on hierarchical namespaces. This provides file system performance for an object storage. We get Hadoop-compatible access for all frameworks that use Apache Hadoop distributed file system. It supports high throughput for input and output intensive analytics and data movement. And even more fine-grained security like access control lists for the file or folder level on top of role-based access control. Azure Data Lake is designed to store large volumes of data in its raw format, simplifying management of diverse data types. Azure Data Lake enables data democratization. Teams across the organization can access and analyze the same data using the tools they prefer, helping turn raw data into insights faster and more consistently. We choose Azure Data Lake when we need central repo for large volumes of diverse data that will be analyzed by many teams and tools. It supports both batch and real-time data ingestion from services like IoT Hub, Event Hub, or Stream Analytics. This is a native match for modern data platform that mix historical and streaming data. For example, a large retailer uses Azure Data Lake to collect sales, inventory, and customer behavior data from hundreds of stores, enabling different departments to analyze trends and optimize operations in near real time. So, when do we use blobs and when do we need to use data lakes? Both of them can handle any data type. we choose data lakes when we need an analytics-first approach. Data lakes support hierarchical namespaces. Blobs are flat-structured. We use data lakes when we need HDFS compatibility. Both of them support role-based access control, storage account access keys, and shared access signatures. But for data lakes, we also have ACLs for the file or folder level control, which is huge for multi-team analytics. If we are a media company, we store raw video files and thumbnails in Azure Blobs for fast app delivery. We will store the viewer logs and playback events in Azure Data Lake to run a large-scale analytics on audience behavior. How do we move and orchestrate data into our storage? We can design a data integration solution with Azure Data Factory. When we are designing a modern data platform, one of the first questions we face is how data actually moves through the solutions. Azure Data Factory is a service that sits in the middle of this conversation. Think of it as an orchestration layer. It does not store the data. It does not replace analytics engine. Instead, it coordinates how data is extracted, transformed, and handed off between services across Azure, on-premises, and SaaS platforms. From an architecture perspective, Data Factory lets us describe those flows as pipelines, so data movement becomes repeatable, governed part of our overall design rather than one-time process. The real value shows up in flexibility and scale. It's fully managed, serverless-based solution. It simplifies and enhances CI/CD through built-in connectors and templates with low-code, no-code. These features enable faster development cycle, reduce manual configuration, and help teams automate data workflows more efficiently. Azure Data Factory allows us to focus on the bigger picture, how data support insights, reporting, and downstream decision-making across the solution as a whole. This is how we can use the many model architecture approach to scale machine learning models. Azure Data Factory retrieves data from the source database and copies it into the Azure Data Lake. Azure Machine Learning uses pipelines for training and promotion. It is deployed to a managed endpoint for near real-time scoring. Predictions are saved into Azure Synapse Analytics. Then, Microsoft Power BI connects to the model prediction to retrieve and aggregate results for presentation. Now, let's talk processing, especially when Spark is involved, Azure Databricks. If the lake is the storage, Databricks is the collaborative kitchen where data get prepped and cooked. Azure Databricks is a collaborative, fully managed platform designed to accelerate big data and machine learning initiatives. It unifies data engineering, analytics, and data science teams on a single environment powered by Apache Spark, eliminating the need for infrastructure management. With dedicated workspaces for SQL, data engineering, and machine learning, Azure Databricks streamlines everything from interactive analytics, scalable batch processing, and advanced model training. Some common use cases including preparing unstructured dataset, building robust data pipelines with Delta Lakes, executing large-scale analytics, and supporting end-to-end machine learning workflows. Azure Databricks service model ensures rapid data processing, seamless team collaboration, and flexible scalability to meet business needs. Let's check out the Medallion Lakehouse baseline architecture. First, data is ingested from an on-premises source system to Data Lake storage using Azure Data Factory with self-hosted integration runtime. Delta Lake provides an open layer format that supports data versioning, enforces schema, and ensures ACID compliance. Data is organized into the following layers. The bronze layer holds all raw data. The silver layer contains cleaned and filtered data. The gold layer stores aggregated data that is useful for business analytics. SQL database is used to support the enterprise data modeling requirement. Power BI is used to create management information dashboard from the enterprise model. To enable collaboration, governance, reliability, and security, Microsoft Purview provides data discovery services, a unified catalog, and governance insights across the platform. Azure Site Recovery supports the backup and recovery for virtual machines, which provide the compute to the Data Factory, required to ingest from an on-premises. For data integration and analytics solution, we can design for Azure Synapse Analytics. If our question is, how do we run end-to-end analytics platform in Azure? Synapse is usually the answer. Azure Synapse Analytics is an integrated analytics platform designed to bring together data integration, enterprise data warehousing, big data analytics, and visualization all in one service. We choose Azure Synapse Analytics when we need to work with multiple data sources, integrate directly with an existing data lake, or enable code-free ETL for data flows alongside Spark-based analytics. It is also becoming valuable when machine learning is part of the architecture, since Synapse is built in for integration with Apache Spark or Azure Machine Learning. The key benefit here from architectural perspective is simplicity. One service that supports data integration, analytics, and exploration without stitching together multiple platforms. This means easier governance, clearer design patterns, and the flexibility to support everything from traditional reporting to real-time and predictive analytics in a single scalable solution. A common pattern is the data lands in the lake. Analysts query the serverless SQL pool, and curated layer feeds a dedicated pool for dashboard. Let's break down the Synapse Analytics component. Synapse SQL pools are two models, dedicated for predictable performance and cost, or serverless for on-demand queries over the data lake. Spark pools, managed Spark for ETL, data engineering, machine learning, support multiple frameworks. Pipelines. It's the same data integration engine as Data Factory, but it is embedded in the Synapse Studio. Synapse links provide us near real-time analytics over operational store like Cosmos DB without heavy ETL. The Synapse Studio is the unified UI that allows us to manage everything. So the SQL pool is used when you want to run queries against the SQL. The Spark pool is designed for transforming and modeling data. And pipelines are there to automate and repeat data processes. So what is the outcome? First, descriptive analytics. What is happening? This often maps into a dedicated SQL pool in structured warehouse. Diagnostics. Why is this happening? That often maps to exploratory queries. Serverless SQL over the lake is a perfect match for that. Prediction. What is likely to happen? For that, we can leverage the Spark and machine learning integration. Prescriptive. What should we do? Decisions, actions based on near real-time insights. So descriptive tells you sales dropped. Diagnostics tell you in which region. Predictive tell you it will continue. Prescriptive tell you restock X and discount Y. For data warehousing and analytics. For each data source, any updates are exported periodically into a staging area in the Azure Data Lake storage. Azure Data Factory is incrementally load the data to the Azure Data Lake into staging tables in Azure Synapse Analytics. The data is cleansed and transformed during this process. After loading a new batch of data into the warehouse, a previously created Azure Analysis Service tabular model is refreshed. The semantic model simplifies the analysis of business data and relationships. Business analysts use Power BI to analyze the data via Analysis Services semantic model. Let's compare the services. Azure Data Factory is primarily an orchestration and integration solution. Synapse is a full data warehouse solution that includes pipeline plus query engine. If you need a standalone integration service you can use across many projects, Azure Data Factory is a clean choice. If we need integration and analytics engine in one studio, Synapse wins. Databricks is the best-in-class Spark collaboration enablement, optimized runtimes, strong machine learning tooling, great when Spark is the center of gravity. Synapse is a strong choice when we need SQL, Spark, pipelines, and Studio all together, especially if the organization leans heavily on T-SQL and warehousing patterns. And yes, you can combine them. Many real architectures use Synapse for warehousing or SQL-based queries, and Databricks for heavy Spark engineering. We can also consider Microsoft Fabric, our newer end-to-end analytics platform that brings together experiences across Power BI, data engineering, data integration, and warehousing in a unified storage concept called OneLake. Now, let's switch gears from batch to real-time. Design Azure Stream Analytics solution for data analysis. Azure Stream Analytics is a fully managed stream processing engine built to analyze high volume of streaming data in real time. Its job is simple: get input, query it, send output. It ingests data from Azure Event Hub, IoT Hub, and Azure Blob Storage. The query, which is based on SQL query language, can be used to easily filter, sort, aggregate, and join stream data over the period. You can also extend the SQL language with JavaScript and .NET user-friendly functions. The output read the data into the storage systems like Blob Storage, Azure SQL, Azure Data Lake, or Cosmos DB. Then, sends the data for Power BI for real-time visualization. Store the data in a data warehouse service like Azure Synapse Analytics to train a machine learning model based on historical data or perform batch analytics. You can trigger a custom workflow by sending the data into Azure Function, Service Bus Topics, or Azure Queues. Let's take a smart greenhouse for example. Sensors stream humidity. Stream Analytics detects it as it's raining. It triggers an action to stop watering before your plants get flooded. Let's explore a scenario. We have a taxi company that collects data about each taxi trip. There are two separated devices sending data. The taxi has a meter that sends information about each ride, the duration, the distance, the pickup, and the drop-off location. A separate device accepts payments from customers and sends data about the fares. The taxi company wants to calculate the average tip per mile driven in real time in order to spot trends. The pipeline ingests data from two sources. Correlate the record in two streams. And calculate a rolling average across a time window. The results are stored for further analysis. Time to review what we learned. Aggreko, a global provider of temporary power and energy services, uses Azure Synapse to boost operational efficiency and enable just-in-time equipment supply. Previously, their batch data ingestion took 4 hours and ran every 8 hours, causing significant data lag due to daily warehouse rebuilds. With Azure Synapse, ingestion time dropped to under 5 minutes, making data available for analytics pipeline in near real time. This change saved the team 30 to 40% of their time, allowing them to focus more on business challenges instead of technology issues. In this session, we covered design a data integration solution with Azure Data Factory, design a data integration solution with Azure Data Lake, design a data integration and analytics solution with Azure Databricks, design an integration and analytics solution with Azure Synapse Analytics, design for Azure Stream Analytics solution for data analysis. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topics on Microsoft Learn at aka.ms/learn. I'm Amit Mir. Happy learning.